This is a little video on multiplying radicals. In each of these, we're going to multiply two radical terms together. And in this case, we're going to use distributive property of a monomial multiplied by a binomial. It's basically a lot like simplifying, except you're going to have the urge to want to multiply these numbers together. Don't. Prime factor them and then merge all their prime factors together, and you'll get lots of factor pairs that you can pull out perfect squares. So 6 breaks into prime numbers 2 times 3. 18 is 2 times 9. So 2 times 3 times 3. So when you multiply those, you get 6 times 18 under the radical, but instead of multiplying them together and getting a big number, leave them all broken apart like this. So I've got 2 times 3 for the 6 times 2 times 3 times 3. And every pair is a perfect square that's going to come out. So I have these 2's, so a 2 will come out. And I have those 3's, so a 3 will come out. So 2 times 3 comes out, and this square root of 3 stays in. So I get 6 times the square root of 3. Okay, second one, 2 root 5 times 5 root 10. So what we can do is we multiply the whole numbers out here together, the 2 times 5, the integers, and the radicands under the radical can be multiplied together too. But again, we're going to want to break them apart. So 5 is just 1 times 5, but 10 breaks into 2 times 5. So I'm going to get this 2 times this 5 on the outside times, under the root sign, the 5 times the 2 times 5. And as you can see, I've got a pair of 5s. So a 5 will come out to the front. So I've got 5 times 2 times 5. And the square root of 2 will stay in. So this is 10 times 5, or 50, times the square root of 2. Again, no perfect squares are left under the radical. Nothing that can be broken down further. With this third one, negative 2 times the square root of 24a times 4 times the square root of 8a to the 4th. So let's see here. Let's break down the 24. This is 2 times 12, which is 2 times 6, 2 times 3. And 8 is 2 times 4, which is 2 times 2. So I'm going to have a negative 2 times a 4 on the outside times the square root of, and I'm going to have 1, 2, 3, 4, 5, 6. Let's just call that 2 to the 6th. And then I'm going to have an a to the 1st times a to the 4th. And I'm going to leave that because I want to have even number exponents if I can. So the square root of 2 to the 6th, or 2 times 2 times 2 times 2, is 2 to the 3rd, right? So I'm going to pull out a 2 to the 3rd to the front, and negative 2 times 4 is a negative 8, and an a will stay in, and the square root of a to the 4th will come out, which is an a squared. So all that's staying under the radical is the single a. So 2 to the 3rd is 8 times negative 8 times a squared times the square root of a. So this becomes negative 64 a squared times the square root of a. Okay, so instead of listing out all of the 2's and circling the pairs and realizing that from 6 2's, I'm going to get 1, 2, 3 pairs. That's why the 2 to the 3rd comes out. Okay, so last one. We're going to multiply a monomial by a binomial just using our distributive property. That's one way to do it. So the square root of 5 times the square root of 3 is the square root of, under the radical, 5 times 3, because they're both prime numbers, minus the square root of 5 times the square root of 75, is the square root of 5 times 75. Now 75 is 3 times 25, which is 5 times 5. So I'm going to have the square root of this. Cannot be simplified anymore. It's not like multiplying. So that's going to be square root of 15 minus, and here I'm going to have a pair of 5s, and I'm going to leave a 3 and a 5 under the radical. So a 5 will come out from here, and what will be left is the 5 times 3, or the 15. Okay, so one root, this is square root of 15 minus 5 root 15. So think of this like an x. 1x minus 5x would be negative 4x, right? So when this radicand is the same, that means whatever is under the radical is exactly the same, then I can add them or subtract them. So they're like terms. So 1 times the square root of 15 minus 5 times the square root of 15 is negative 4 times the square root of 15. And that's it.